Alright, let's talk about our last conic here of the unit, and that's hyperbolas. So as I've done with the other ones, I want to just give you a formal definition. Hyperbola, set of all points in a plane, the difference of whose distance is from two distinct points, we call those foci again, or foci, is a positive constant. Now think how that's similar to ellipses. The difference was ellipses was the sum of the distances. Hyperbolas is the difference, so you subtract them. Just like ellipses, hyperbolas can have two different orientations, so they can open outward, okay, along the x-axis, or they can open vertically, up and down, along the y-axis. So let's just describe these a little bit further. A couple key characteristics for hyperbolas. And so their center is at HK, just like all our other conics that we've dealt with. Now they have two vertices, okay? Now like an ellipse, those enclosed, these are not, they open away from each other, but their vertices are A units from HK, whatever the center is. Now just like we saw with ellipses, by the way, all of these that you're going to deal with are going to be centered at 0, 0. Okay, they don't have to be, but in this lesson, they're just kind of introducing things to you. They're all going to be from the origin 0, 0. The foci are inside now the parabola, where ellipses, parabolas, remember they're inside. So foci here are C units from HK, just like ellipses are, okay? And now we have this key relationship. C squared equals A squared plus B squared. So in this case, for hyperbolas, C is the largest value. And so if I actually drew a triangle here, let me just sketch that triangle. So C would actually be the hypotenuse now. This would be A, that would be B. So that matches Pythagorean theorem exactly, okay? Now here's the equations. They look very, very similar to ellipses, except they're subtracted rather than added. One other key difference, A squared stays under X under the first term no matter what. So A and B could be bigger than A, it doesn't matter. For ellipses, A was always bigger. For hyperbolas, that's not the case, alright? So how do you tell what's going on? Well, if the X squared part is first, if it's positive, then we open horizontally, we open in the X direction. If the Y part is first, if it's positive, then we open vertically, we open in the Y direction. That's how I like to remember them. Now these equations, again, they look kind of complicated. We've got HK built in, but just like with ellipses we talked about, all of these that we deal with as we introduce it are going to be centered at 0. So the equations are going to look quite a bit simpler. X squared over A squared equals Y squared over B squared equals 1. And then same thing here, Y squared over A squared minus X squared over B squared equals 1. Okay? Couple type examples that we'll deal with. Graph. Well, of course, you could just go plug this into Desmos.com excuse me, and see what it looks like. But I want to show you, how we would go about this. So we want to make it match our equation. So we're going to make it equal 1. So we divide 100 by both sides. And let's simplify. So that'd be x squared over 4 minus y squared over 25 equals 1. Notice bigger number under the y. That's okay. So x, if we went over, now that's an a squared, remember. So if I went over 2 and over 2, my y is going to be, my b is going to be a 5. So if I went up 5 and down 5, now the way you graph these, you make a little box. Okay, just kind of lightly dotted lines. If I sketch a box, and you can kind of see that. And then through these corners, right through the origin of the center, and through the corners here of my box, you just kind of sketch these dotted lines. They're asymptotes. Now this thing starts with x squared, so it's opening in the x direction. So now I just kind of come in, I hug these asymptotes, go through the vertex there, and sketch in my hyperbola. Okay, you don't need to worry about C or anything. We could find it, but you don't need it to sketch it in. Let me show you over here. I've already typed it in. If you notice there, look, that looks basically like we drew. Okay, it doesn't show the asymptotes and things, but that's how you go make a sketch. Okay, how about a problem like this? What equation corresponds to the graph? So they give us a graph. They want us to choose the correct equation. Well, let's look at it. First of all, it's opening up or down. So that tells me the y has to come first. So I can automatically cross that out. I could cross that out. Well, let's see how far it goes up. 1, 2, 3. So there's a vertex right there. So that means that under my y squared, there's going to have to be a 3 squared. Hey, right there's my equation. Okay, so you can cross that out. Now, worst case, of course, you could go type these equations into Desmos and check, see which one matches, right? But again, it should be pretty straightforward to identify the key characteristics from what they give you. All right, I hope that helps you, kind of get you started on this lesson. Hey, that's the last lesson in our conics unit. Not too bad, I hope.